Pak Dr. Diano, Dekan Fakultas Kesehatan Masyarakat, Pak Nur Juli, Wakil Dekan Akademik Kemahasiswaan, Bu Dr. Yusniar yang nanti akan selaku moderator, dan Prof. Majura, narasumber kita yang selalu mendampingi Undip, FKM Undip ini, Prof. Majura. Terima kasih sekali berbagi ilmu dengan kita. Dan mahasiswa sekalian yang saya cintai, puji syukur pada pagi hari ini kita bisa bertemu dalam ruang Zoom meeting untuk menimba ilmu dari Prof. Majura terkait dengan air pollution and diseases begitu ya. Nanti intinya berada di beliau dan Bu Yusniar. Untuk itu kami mohon untuk Pak Dekan, Dr. Budiono bisa mengantarkan acara kita ini. Untuk itu monggo Pak Budi bisa diantarkan.
Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh. Alhamdulillah, Bapak Ibu sekalian diberikan kesempatan untuk bertemu. Yang saya hormati Prof. Mazura Zahani dari Universitas Kebangsaan Malaysia. Kemudian juga ada Ketua Program Studi Magister Kesehatan Lingkungan, ada Dr. Mursyid Raharjo, kemudian juga ada Dr. Yusniar Hanani Darundiati selaku Ketua Departemen Kesehatan Lingkungan. Kemudian juga ada Pak Wakil Dekan 1, Vice Dean for the Academic Affairs, Academic and Student Affairs, jadi dari Fakultas Public Health, Pak Dr. Nur Juli, dan Bapak Ibu dosen di Departemen Kesehatan Lingkungan FKM Undip maupun juga teman-teman dosen lain, kemudian juga panitia, kemudian para mahasiswa dan juga para pemerhati maupun praktisi kesehatan lingkungan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Bapak Ibu sekalian, Alhamdulillah alamin, kita diberikan kesehatan, keselamatan, dan juga banyak hal lain terkait dengan apa yang telah kita nikmati selama ini ya. Jadi apapun itu, sekecil apapun itu wajib kita syukuri, dan sholawat dan salam kita sampaikan kepada Nabi Muhammad SAW. Semoga kita mendapat tambahan di hari akhir, amin. Alhamdulillah Bapak Ibu sekalian, hari ini kita akan menyelenggarakan visiting profesor. Terima kasih Prof. Mazura sudah hadir pada acara pagi hari ini terkait dengan air pollution and diseases. Jadi sebenarnya kalau kita lihat air pollution itu sangat-sangat luas. Jadi sangat banyak agents, apakah physical, chemical maupun biological agent itu ada di air pollution. Apakah itu di dalam maupun di luar ruang. Jadi banyak sekali dan sangat luas. Dan saya yakin kalau hal itu expose to manusia begitu, to human, maka akan mengakibatkan berbagai dampak. Jadi salah satunya ya gangguan kesehatan, apakah di saluran pernafasan, atau apakah di gangguan jantung, atau saluran pembuluh peredaran darah, ataupun yang lain, tergantung dari agent itu sendiri di mana bisa berinteraksi dengan secara biochemical maupun biotransformation di dalam tubuh kita, metabolisme dan sebagainya. Apakah justru metabolitnya itu yang menjadi lebih toksik atau yang tidak, dan sebagainya. Jadi itu beberapa terkait. Jadi yang general mungkin yang kita ketahui seperti karbon monoksida, sulfur dioksida dan sebagainya itu mungkin juga apakah logam berat seperti plumbum, seperti mungkin kadmium dan sebagainya, itu juga semua bahan-bahan yang ada di udara atau di dan aktivitas-aktivitas kita baik secara antropogenik atau aktivitas manusia itu misalnya transportasi, menggunakan bahan bakar dan menghasilkan bahan-bahan tadi, emisi tadi, kemudian juga proses industri, pertambangan dan sebagainya juga banyak menghasilkan polutan yang ada di udara, termasuk yang natural resources, misalnya seperti erupsi gunung itu juga akan menghasilkan berbagai macam bahan logam berat dan ataupun mungkin partikulat PM2,5 dan atau PM10 dan sebagainya, sehingga semua bisa berdampak pada gangguan kesehatan tergantung jumlah dosis dan frequent exposed to this agent gitu. Jadi itu Bapak Ibu sekalian yang bisa saya sampaikan apa dan bagaimana, seperti apa contoh-contohnya. Saya kira pengetahuan, pengalaman dari Prof. Mazura ini sangat-sangat luas, sangat-sangat sudah banyak dan beliau banyak sekali publikasi. Nanti mohon bisa aktif berdiskusi untuk itu, untuk mengetahui lebih jauh, lebih banyak, karena ini ilmu pengetahuan dan pastinya akan sangat berguna untuk kita semua. Saya kira itu yang bisa kami sampaikan, Bapak Ibu sekalian. Nikmati atau berdiskusilah dengan aktif di kegiatan ini, dan mudah-mudahan bermanfaat untuk peningkatan pengalaman pengetahuan kita. Terima kasih. Mohon maaf jika ada yang kurang berkenan, atas izin dari Bapak Ibu sekalian dan tentunya Allah Subhanahu wa taala. Acara visiting Professor Pollution and Diseases secara ini, bismillahirrahmanirrahim, saya buka. Terima kasih Bapak Ibu sekalian. Mohon maaf saya langsung the next agenda. Mohon maaf.
Monggo.
Salam Prof. Mazura. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Atur suhun Pak Budiono sudah membuka acara kita, dan untuk berikutnya monggo Bu Dr. Yusnia bisa memandu acara diskusi pada pagi hari ini. Kita ada waktu sekitar 1,5 sampai 2 jam Bu Yusnia, sehingga istilahnya ilmu dari beliau Prof. Mazura itu bisa memberikan paparan pada anak-anak sekalian. Saya serahkan sepenuhnya Bu Dr. Yusnia.
Ya, terima kasih Pak Mursyid. Selamat pagi. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Yang terhormat di sini ada Pak Nur selaku Dekan FKM, Wakil Dekan bagian akademik. Kemudian juga ada Pak Mursyid selaku Ketua Program Studi Magister Kesehatan Lingkungan. Mungkin juga yang terutama Prof. Mazrura Sahani selaku narasumber kita, our speaker today from Universitas Kebangsaan Malaysia. Juga rekan-rekan mungkin sesama dosen dan adik-adik mahasiswa semuanya. Pagi ini kita akan mendengarkan paparan dari Prof. Mazrura terkait dengan air pollution and diseases. Namun sebelumnya mungkin akan saya bacakan dulu CV beliau. Ya, di sini akan saya share dulu ya. Ya, speaker kita pada pagi ini Profesor Dr. Mazrura Sahani. Prof. Dr. Mazrura Sahani is a public health consultant and physician specialized in the field of environmental and occupational epidemiology. She is the founder, president of Malaysian Society of Environmental Epidemiology, or MySEE, which was established since 2011 and now hold the position as the vice president of MySEE. She has advocated various environmental epidemiology activities in Malaysia. She sits in the panel of experts under Technical Working Group 10 for the National Environmental Health Action Plan or NEHAP, Malaysia. Previously, she has been appointed as the national and international panel reviewer in various committees on public health, among others, the Technical Committee in Establishment of the Malaysia Air Quality Standard 2015, a steering committee of ASEAN Initiative of Research in Climate Change and Air Pollution, or AIRCAP, since 2018, and in Advanced Institute on Health Investigation and Air Sensing for ASEAN Pollution, or AI on High SF initiative since 2020. In 2020, she led a pioneer project funded by UNICEF on impact of climate change on children, a Malaysian perspective sector-based evidence analysis and recommendation for policymaker and stakeholder, and she is also a member of the YIPU Task Force Climate Change Impact and Adaptation for Water Transformation 2040 study. She also led in 2021 a research consultant project for the NBR on the health co-benefits of electric vehicle growth in Malaysia. She was also the lead consultant project for the Malaysia Department of Occupational Safety and Health in the development of the new medical surveillance program in the workplace. For more than 20 years, she has conducted health impact assessment for substantial numbers of consultancies for the government and various agencies locally and internationally. Recently, she retired from the Faculty of Health Sciences, University Kebangsaan Malaysia. Prof. Dr. Mazrura remain active in research, academic, and community empowerment, and have a passion in establishing transdisciplinary approaches for community resilience to address challenges and nexus environmental sustainability, climate variability, and engineering diseases. I think it's enough. And now we are going to the presentation. Okay. For the time, we will give this time and screen to Prof. Mazrura Sahami. We will have, for the next session, we have question and answer discussion. And for now, please, Prof. Mazrura Sahami, to present your material. Time and screen are yours. Thank you.
Terima kasih Dr. Yusnia. Assalamualaikum warahmatullahi taala wabarakatuh dan salam
Waalaikumsalam warahmatullahi wabarakatuh.
Dan juga selamat pagi. Terima kasih banyak-banyak saya ucapkan kepada Undip, terutamanya Pak Musid, Dekan, Pak Budi tadi, dan juga semua yang telah menjemput saya untuk bersama berkongsi pengalaman saya di bidang ini. Saya mohon maaf, saya tidak dapat hidupkan kamera saya, jadi tidak kelihatan saya di sini. Ada masalah teknikal sedikit. Jadi saya orang lama ni tidak pandai nak mengubahnya. Jadi juga saya ucapkan ribuan terima kasih kepada semua mahasiswa yang juga bersama dengan kita pagi ini. Jadi saya ingin teruskanlah ya. Saya sebenarnya baru retired, maksudnya pensiun. Jadi sekarang ni saya mempunyai sepenuh masa bekerja sendiri ya. Alhamdulillah. Jadi saya walau bagaimanapun saya amat berbesar hati dapat memberi kita panggil kuliah ini untuk berkongsilah apa yang saya telah jalani dan juga pengalaman saya di bidang kesihatan lingkungan ini sejak tahun 1997. Jadi sudah lebih 20 tahun itu. Alhamdulillah. Jadi saya akan share untuk hari ini adalah diseases and air pollution and diseases, di mana merupakan satu bidang yang saya sangat minati dan telah saya lakukan banyak penyelidikan di bidang ini untuk Malaysia, terutamanya di bawah kumpulan atmospheric research di Universiti Kebangsaan Malaysia, di mana kalau di Universiti Kebangsaan Malaysia, ketua untuk atmospheric research adalah Profesor Muhammad Talib Latif, dan sekiranya apa-apa isu kesihatan saya yang mengetuai isu-isu kesihatan berkaitan dengan kesihatan lingkungan ini. InsyaAllah saya cuba share ya, saya punya slide.
Ya, silakan.
Jadi saya untuk air pollution and diseases. Jadi saya ada dua kuliah lecture. Yang pertama adalah lebih kepada air pollution sendiri, dan yang kedua lebih kepada melihat tentang diseases, air pollution related diseases, ataupun saya lebih suka dikenali sebagai air pollution epidemiology. Ya. Okey, jadi saya sekali lagi ingin ucapkan ribuan terima kasih kepada FKM, Fakulti Kesihatan Masyarakat Undip, yang sekali lagi menjemput saya. Kali pertamanya kalau saya tidak silap 2021 ya. Ya, 2 tahun lalu.
Ya betul Prof. 2021.
bersama dengan mahasiswa-mahasiswa untuk program Master in Environmental Health. Ya. Okey, saya juga mewakili my society, MIC, Malaysian Society for Environmental Epidemiology, dan juga my own company lah, WeCare Health Consultancy. For this, I usually use this consultancy company for my health impact assessment project, which is governed by the law under EIA Prescribed Activity Order 2015. Jadi maafkan saya, mungkin saya berbahasa tu campur-campur ya, bahasa Inggeris dan bahasa Malaysia. Most of my English. Yeah. Untuk MIC, since establishment 2011, kami setiap tahun menjalankan aktiviti training especially, and also insyaAllah tahun depan kami akan host ISE Western Pacific, International Society Environmental Epidemiology Conference di Asia Pacific region. Kami kalau tahun ini ISEE yang besar itu akan dijalankan, the conference akan dijalankan di Kaohsiung, Kaohsiung, Taiwan, dan insyaAllah kami baru saja lobby untuk MIC bersama Universiti Malaysia Sabah akan host the International Society Environmental Epidemiology Conference for the Asia Pacific Conference. That means untuk region kita. Jadi harap-harap ramai pensyarah dosen-dosen dari Undip dan juga mahasiswa yang akan bersama kita. Ya, insyaAllah.
InsyaAllah.
Itu kemungkinan masih lagi dalam proses perbincangan. Kemungkinan insyaAllah bulan Juni tahun hadapan 2024 kita akan host the international conference. Sebenarnya MIC telah host the same international conference ISEE. Dulu ia hanya dikenali sebagai ISEE AC, Asia Chapter. Sekarang ni kita sudah includekan Australia dan juga beberapa negara di Western Pacific. Jadi ISEE regional ni telah ditukar nama kepada Asia Pacific. Ya? Dan di bawah umbrella the bigger ISEE, International Society Environmental Epidemiology. Ya? Okay. Untuk itu memang banyak activities research yang saya jalankan, terutamanya untuk air pollution and diseases. Saya banyak juga merujuk kepada pakar-pakar yang ada di dalam ISEE, terutamanya di US, Canada, Europe, kan? Dan juga kalau di Asia ini kita ramai pakar-pakar untuk air pollution and diseases dari segi environmental epidemiology, terutamanya di Japan, di Taiwan dan juga di Korea. Itu kebanyakannya pakar rujuk kita lah, ya, yang biasanya kita berkongsi dari segi di modeling, di advanced statistical modeling. Jadi saya telah menjalankan this type of activity since I think our bad haze in 1997 for Malaysia. Tapi melalui proses yang sangat lama, sebab semasa itu capacity to analyze this type of air pollution related diseases masih sangat kurang. Jadi saya sendiri bersama rakan saya, biostatistician, kami mencari pakar-pakar dunia bagaimana untuk mengajar kami menjalankan this analisis untuk environment air pollution epidemiology, di mana salah seorang graduan saya adalah PhD student yang sekarang ini menjadi pakar untuk menjalankan this type of analysis, yang sekarang masih lagi bekerja dengan Institute for Medical Research, Kementerian Kesihatan Malaysia. Terus kami masih lagi bekerjasama lah dengan erat my PhD graduates, Dr. Wan Rosita Wan Mahyudin, dan juga ramai lagi selepas itu PhD students yang bergraduasi tentang this type of bidang lah. Okay, for air pollution and diseases, untuk lecture yang pertama ni, saya rasa telah ada ya kuliah untuk mahasiswa untuk air pollution ni. Sudah ada. Jadi saya tidak perlu bagi basic sangat lah ya, jadi boleh dilajukan. Di mana yang saya akan memerlukan sedikit penekanan, terutama update yang baru untuk air pollution ini. Itu mungkin saya akan ambil masa sedikit, tapi kalau yang very basic tu mungkin saya akan bentangkan dengan agak pantas lah, dengan cepat.
Yeah.
So in terms of this fundamental of air pollution, this is my lecture outlines, the fundamental of air pollution. Why should I care about air pollution, the definition of air pollution and what is air pollution, sources, mechanism of air pollution and factors influencing air pollution, and also the measurement and air pollution index. Basically, this measurement and air pollution index applied for Malaysia. Di Indonesia pun saya rasa hampir sama. Kita di Malaysia pakai API, di Indonesia pakai Air Quality Index ya, AQI.
Yeah.
And for air quality monitoring, kita sudah ada di Malaysia sejak 1995 di Continuous Air Monitoring Station, dan dikembangkan selepas jerbu yang besar itu 1997 daripada 25 monitoring station kepada 65 sekarang, the whole country. Peninsular and also in East Malaysia, and also the outlines on the haze air pollution. So for today's the first lecture, hopefully we could achieve the learning objective in terms of understand the basic of air pollution sources and factors affecting air pollution, describe the measurement of air pollution and API. Ini saya tidak akan pergi lebih detail sebab saya bukan pakarnya. Pakarnya saya rasa di Indonesia pun ramai, dan juga untuk air pollution, dan juga di Malaysia kebanyakannya kami rujuk kepada Profesor Talib. Dan understanding air quality monitoring yang dijalankan, dan juga understanding issues pertaining to air pollution, haze and its health impact. So I think air pollution has gained a lot of interest, especially it started in 1952 for London Killer Fog, where that time we have high level of particles and sulfur dioxide from coal for heating and power. This is during winter time, di mana zaman dulu kan mereka tidak ada banyak yang electricity, betul, heater yang elektrik kan, jadi perlu gunakan coal untuk pemanasan di rumah-rumah, dan disitulah di mana daripada coal burning itu keluarnya particles dan juga sulfur dioxide. Then also during the winter season, the weather trapped the pollutants, and during this time they observed that there were daily death rose to several times than normal. It was estimated for the death to be 3,000 to 4,000, but when they recalculated, when they have fine-tuned the analysis, it seems that the later analysis showed that the death increased from 10 to 12,000 during the winter 1952 to 1953. Jadi kita nampak sangatlah semasa winter season, that means towards end of the year, di sini yang terdapat peningkatan, terutamanya because of the sulfur dioxide contents was very high, dan juga kematian juga sangat tinggi during the London smoke. So the air pollution is a health issue, and it is a silent killer. Then air pollution is major environmental risk to health, and hopefully by reducing air pollution level, we could reduce all the air pollution related diseases, especially death due to the air pollution, such as due to the stroke, heart disease, lung cancer, and both acute and chronic and acute respiratory diseases, including asthma. So in the WHO regionally has estimated that over 2 million people died because of in Southeast Asia region, and also in the Western Pacific region because of the air pollution. And over 90% of the population breathes polluted air, especially in the urban area. So we can see that in urban area, especially in most of the urban centers, like in Malaysia, most of our area now are urbanized. We have the annual mean of PM 2.5 of up to 15 to 25. The current PM 2.5 guidelines under WHO 2021 is only 10. I think the WHO has revised the air quality guidelines. Initially, it was up to 25, but now it is 10. So most of our urban cities has exceed the guidelines value for PM 2.5, particulate matter less than 2.5 micron. So for definition of the air pollution, we have the air contaminants, all materials other than the normal clean composition of air. And the air pollutants are contaminant causing damage and harmful effects. And the air pollution consists of a mixture of gases and particles that are formed from burning fuels and other materials or photochemical reaction in the atmosphere. And the presence of air pollution in the indoor and outdoor air of substances in concentration and duration sufficient to produce measurable adverse effect on human beings, animals, and vegetation and materials. So this is the complex mixture of air pollution. It's a very good representation of what the air pollution looks like. So we have in the air pollution, actually, we have all the molecules and also the virus, bacteria, red blood cells, all the cells, pollens, spin, and also sands. So these are the diameter. We have the particulate matter up to 10 micron, where we call it PM10, and if it is up to 2.5, we call it fine coarse PM 2.5, and it is lower than the 100 nanometer, sorry, it is ultra fine. And the sources of this air pollution, mainly the fossil fuel combustion. At region level, we have the coal and industry and also the power plant. At locals, we have the house, commercial, and fire, especially for the biomass and household. And especially in the town center, we have the mobile sources from ships, traffic, and diesels. And the particles that are of concern of health are mainly the small particles, such as the fine particulates less than 2.5 or PM 2.5, or even the much smaller, the ultra particles. So they are all very dangerous, and at the same time, these fine particles attach with it the other components such as the nitrate, sulfate, metals, elements such as organic and elemental carbon. And if we look into the size of the fine particles, is almost if we cut our PM 2.5, it is about our human hair, which is about 70 micron. So our PM10 is about 10 micron. It's much smaller than the human hair, and even the small particle is less than 2.5, and fine particulates is very difficult to see. So we have to use the electron microscope. So the sources of pollution, either man-made or natural. So man-made sources contribution is less natural, but and cause imbalance of nature, and increasing through development process, especially the industrialization has changed our air pollution composition from better to worse. And the increase in mass and toxic air pollution. So when we talk about, generally, when we talk about air pollution, we are focusing more on the criteria air pollutants. I mean, the main air pollutant, the 5 or 6 air pollutants such as PM10, SOx, NOx, ozone, and also Malaysia has included PM 2.5 in our MAAQS. So in terms of the criteria polluted, we include also PM 2.5 in our monitoring. At the same time, we also have lead. I think similar to Indonesia, where the criteria pollutants are all the 6 or 7 main criteria pollutants. But at the same time, for toxic air pollutants, Malaysia has no guidelines for the toxic air pollutants, but this toxic air pollutant, especially in industrialized area, especially from the emissions from the stationary sources. So we usually, for example, my work on the HIA for EIA, Environmental Impact Assessment, we usually use the most stringent air quality guidelines which is available is basically to protect our human health. We usually refer to either California air quality guidelines or as Arizona air quality guidelines, which are more stringent, or even US EPA air quality guidelines. So for the sources, usually when it is located, sources of air pollution, when it is located near to the human, in vicinity of human activities, and it will cause more harmful effects to the community exposed. So we can see that the primary pollutant, basically all this emitted directly to the air, to the ambient environment, such as the carbon monoxide, sulfur dioxide, NOx, ammonia, particulates, and VOCs, volatile organic compounds. But because of the weather and also the heat and oxygens, we could have the secondary pollutants such as the ozone, particulate matter, nitrate, and also hydrogen peroxide, and so on, hydrogen sulfide. So the secondary pollutants form in the atmosphere from interaction with the primary pollutants, with the air, oxygen, and also being stimulated by the heat. Okay, so these are the dominant sources of urban air pollution. Especially we have the urban air particles, basically a lot through the anthropogenic activities, such as from the open burning, industrial emission, urban transportation, power plant, shipping emission, and combustion of peat soil. But at the same time, we also have the natural sources of the urban air pollutants from the wildfires, fire, terrestrial vegetation, volcano, sandstorm, marine sea salt, and also soil or earth crust surface dust. So these are all the dominant sources of air pollutants, and the main sources such as the transboundary, the transportation, and also the industry or power plant. And the source of air pollution, where we could also detail out where most of these sources of sulfur dioxide, basically from the stationary sources, the sulfur dioxide, mainly from the coal power plant, SO2, and also the others, oil, gas, bioenergy, and waste. I was involved with the establishment of the coal-fired power plant in Malaysia. The biggest one is in west coast of Malaysia. That is we call it Jana Manjung, that is in Perak. So I was involved with the HIA since 1997, and when they expand the coal-fired power plant with their more, we call it, from 1,000 megawatt to they have now 5 boilers. So it's more like, it's now more like 3,000 or 5,000 megawatts of the coal-fired power plant, the capacity. And for nitrogen oxide, basically their sources are from the industry, but it's from the fuel combustion, process emission. And for transport, usually it will emit more of the PM particulate matter from their exhaust, and also from the wear and tear, brake and tire. Carbon monoxide mainly from building and heating and lighting. And others VOC from the fuel supply, the extraction, storage, transport, and transformation of fossil fuels, and also the non-energy sources such as the agriculture, solvent, and waste for the ammonia. And factors influencing our air pollution, especially in Asia, mainly home cooking, power generation, industry, traffic, and biomass burning. And for the measurement of the air pollution, we have the measurement unit and averaging time. For particulate matter, we have the weight and the volume. So usually we will measure the filter paper and read it, and also look at the volume per meter cube. And the gases are also weight per volume. We could measure either The unit will be ppm, ppb, and also milligram per meter cube. At the same time, temperature and pressure are indicated if weight or volumes units are used, and 2 units are convertible: temperature, pressure, pollutant molecular weight, and must be given. The averaging time usually for PM 2.5 we use 24 hours, but for most of the gases is the averaging time is 8 hours. The length of time in atmospheric dispersion, testing over which concentration data are averaged to produce the concentration time series. So for most of our measurement for air pollution, the PM 2.5 is 24 hours, or we call it daily average. But most of the gases we use 8 hours, and also we have also 1 hour for the gases average. So the measurement of these air pollutant, especially for the aerosol, we have the real-time sampling. When we, for Malaysia, we have the continuous ambient air quality monitoring or station, CAQM. And they use real-time sampling, which measure this real-time sampling, as I mentioned earlier. We have about 65 monitoring stations throughout Malaysia, and which is a fixed station, and also some that we have at some street level. And this real-time sampling, they monitor the aerosol particles and the reactive gases, and also they have the local meteorological data together, link up from the meteorological department. So most of these monitoring are done by the Department of Malaysia, but at the same time, UKM, we have our own aerosol particles, that is the PNC counter, and the MET data. We combine the data together to use it for our air quality monitoring, or also for research. At the same time, we also have our own sampling, that is intermittent sampling. We can use this mainly for our own monitoring and also for research purpose. We use the high and low volume sampler. For the high volume sampler, usually it is 24 hours and monitoring. And for the low volume sampler, for PM 2.5, it is about for 8 hours. And we can also do some grab sampling, especially for the organic compounds, the VOCs, using Tedler bags, solvent tube, and also we have to analyze it to the using the GCMS, gauge chromatography, mass spectrometer. And all this analysis we could do with the high HVS, high volume sampler, and low volume sampler. For the we can use the ion chromatography, ICP-MS for the elements, especially the elements, heavy metal, the metal compound, and also GCMS for the organic compounds, the elements, especially inorganic compounds. So these are sampling equipment. This is the PNC and the high volume sampler. This is our team, atmospheric team. The high volume sampler, we usually put it on top of the roof, and the ion chromatography and the lab analysis, the GCMS and ICP-MS. At the same time, we've now come up with the low cost sensor. We have ABOX and also AS-Lung, that is air sensor by Prof. Candice from Taiwan. This is the air sensor, the low cost sensor. This is considered cheaper, and it can be used portable. And I will tell you more about this ABOX sensor, which is developed by our atmospheric team, headed by Associate Professor Dr. Shahrul. And also we have the courtesy of the Academia Sinica, Dr. Candice Lang, who has also shared with us the air sensor for portable one. This is all low cost sensor. This ABOX sensor costs about 30,000 ringgit, and the AS-Lung is about 2,000 USD, means 2,000 USD is about 8 to 10,000 Malaysian ringgit. So the potential class of composition, the trace metal, All this we could analyze ionic composition and also semi-volatile organic and the VOCs. The main VOCs that are concerned usually the BTEX, benzene, toluene, ethylene, and xylene. At the same time, for the semi-volatile, we have basically mostly the PAH, polyaromatic hydrocarbon, at least 16 of them. So for Malaysia, I think Malaysia, just to share with you, we are having our rapid urbanization ever since our independence 1970s, and our countries really developed after 20 years. So in 1990s, we are really mostly urbanized, especially in the urban areas, and we have, due to this rapid urbanization, we have increasing anthropogenic activities and high number of urban population, means that the population density in the urban center in most of the cities in Malaysia are very high, and due to this we have a lot of traffic emissions with increasing carbon monoxide, not CO2, as carbon monoxide emission, CO emission, and increasing heat wave episodes and other extreme weather episodes. So when we have increasing heat wave, this is, I think, ever since for the past, I think during the middle of Ramadan, we are facing the heat wave. And now, I think almost 1 month now, we are having a very warm weather, and even this is similar to in 2016, and most of the ministry are in alert situation now. If in case we are facing this situation, they are discussing whether during the heat wave to close the school, or there are other control measures that we have the Clean Air Action Plan that could be activated during the seasons, whether is it heat or air pollution, high air pollution episodes. For the environmental degradation in Malaysia, it has significant impact of human health due to the heat wave and high concentration of air pollutant. So in 2019, Malaysia ranked 50th place among all the countries of the world, and the average PM2.5 concentration of in Malaysia is about 19 microgram per meter cube, and also the PM10, which is above the WHO standards of 20 microgram per meter cube. And the air quality ground level measurement, we have, as I mentioned earlier, we have the CAQM, 65 CAQM monitoring stations. At the same time, we also have manual basically for lead and also for other hazardous pollutant, but it is not throughout the countries. It's only, I think, mainly the manual monitoring station, basically in the capital cities of the states of Malaysia, basically 14 states in Malaysia, that they do the manual monitoring of air quality. So for the CAQM, Continuous Air Monitoring Station, we monitor mainly PM10, PM2.5, NO2, SO2, CO, ozone, and also the meteorological factors. And the we have for Department of Environment, we have the websites that monitor the air quality. That is the APIMS, Air Pollution Information Malaysia system. So it is available, and it's a real-time monitoring. Anybody can just go into APIMS, Air Pollution Index of Malaysia, and to look into what is the current level of the API for Malaysia. So the level measurement in Malaysia, you can see that by Latif et al. When we review our air pollution status, so we have basically this trend of air pollution, basically for PM2.5. We can look at the source of the pollutants according to their sources. Is it according to the type of monitoring? Is it industrial monitoring or urban, suburban, and rural? And this is a trend for 2018 to 2020. Basically, we can, based on this CAQM, we could do all this trend analysis for the PM10, PM2.5, NOx, CO, SOx, and also ozone. So basically for PM10 and PM2.5, if PM2.5 is about 10, the latest WHO air quality standards, so we have exceed for Malaysia in 2021. No, I mean in this monitoring, throughout the monitoring, and even PM10, we of the 25, we almost exceed most of the monitoring, and we can see what are the main sources of the pollutants. Basically, a lot due to the industrial and also urban sources. For haze, smoke haze history in Malaysia, it is we usually use the term haze, smoke haze, because of the biomass burning. It's a state of the smoke haze is a state of poor air quality characterized by the opalescent appearance of the atmosphere and reduced visibility, and caused by high concentration of air pollutant suspended in the atmosphere, and usually exaggerated by the El Nino. And the main pollutant usually during haze, basically they mainly on the PM2.5, PM10, same time ozone, CO, NOx, and SOx. So we can see that for this haze history in Malaysia, the most we have been facing haze since 1980s, and the most severe haze air pollution are in 1997. That is the highest air pollution index. In terms of intensity, it is during the 1997, but in terms of the duration, it is in 2013 and 2015. And if we can see that the haze occurred in Malaysia is also together during the El Nino. All this pink color is during the El Nino phenomenon. So these are the latest air quality guidelines 2021 by WHO. It has been published, as I mentioned earlier. So we usually use now because it's 2021, they have interim 1, 2, 3, 4. So it started with the annual 24 hours PM2.5. It started with, this is the one that is the current one, 35. But in few years time, they will implement the second interim and the fourth interim by after certain years, and then this is all the targeted. So PM2.5 for annual is 10, 24 hours are 25, but PM10 is targeted for 20, 24 hours is 50. So if we look at the trend just now, surely we have exceeded this. If we go into interim 4, we have exceeded the PM10 and PM2.5. So for ozone, they use the 8 hours especially, and also the peak season. NO2 annual and 24 hours. SO2, the 24 hours average, and also carbon monoxide, the 24 hours. And for us to disseminate information about the air quality status of Malaysia, we use the API, and we use this API value, the range, whether it is the status is good, moderate, unhealthy, very unhealthy, and also hazardous. So what does it mean with the good status of API? It looks into the health effects. If it is good, that means without any health effect. But it is, if it is moderate from 51 to 100 API, it does not cause any bad effect. But if it is more than 100, it is unhealthy, means it will worsen the health condition of high risk people. That means people with the heart and lung diseases. And if it's unhealthy, the worsen it worsened the health condition and low tolerance of physical exercise to people with heart and lung complication. And when it is hazardous condition, it has hazardous to high risk people and public health. So this is the value that being used by the authorities, either Department of Environment and also especially Ministry of Health and Ministry of Education, to alert our community, our public, whether we need to close the school, or I think similar to in the COVID situation, where the MCO, movement control order, has to be imposed depending on the API. I think when it is going for hazardous condition, and the most probably MCO will be imposed again. So the API calculation, we use this formula. This is what we using it for API. I won't go into detail. This is not my area of expertise. And the Malaysia Ambient Air Quality Standard, MAAQS, which was established in 2015. We compare. When we did this, I was one of the panel in this MAAQS establishment. We compare mostly our standards with the WHO. That time we used WHO 2006 standard, and also US EPA. The US EPA standards are more stringent. So we usually basically the principle behind this ambient air quality standards is to safeguard the public health. So we need to know what are the threshold value that can give some health effects. That means but at the same time, we have to address the uncertainty factors. So the value usually for the ambient air quality standards are much below than the real health effects that are going to be encountered when the exposure, when the population are being exposed. So we took into account the uncertainty factors when we have this, we come up with the ambient air quality standards. Now we are using, for Malaysia, when we start off with the MAAQS, we have the interim 1 target, interim 2, but now since we are beyond 2020, so these are the level that we use, standard of 2020 to monitor and also to ensure that most of our air quality could achieve these standards. So we have the standards for PM10, PM2.5, SOx, NOx, ozone, and also CO. So if we look into the World Air Quality Ranking, this is through the IQ+. So we can see that World Major Air Quality Ranking, the worst is Delhi, Kaohsiung, Taiwan. This is as of this morning when I look into this IQ+. Santiago, and unluckily Jakarta is top 10, the air quality, the worst air quality ranking. But for 2022, these are all the countries that has the worst air quality. For Indonesia, if also this morning when I browsed to the IQ+, you can also go into this IQ Air form Indonesia. So we can see that in Semarang is about 160, if I'm not mistaken. You are here. So this is Semarang. So the air quality is not so good now, 161, the AQI. But the rest, they are in the good and also moderate status. For Malaysia, this is, I also use IQ+, but they mentioned that the source is actually the APIMS, that's by the Department of Environment. For in Kuala Lumpur this morning, the air quality is moderate, 63. So this is Kuala Lumpur. somewhere here. And so we can also have the other forecast, the 7 days forecast in terms of the meteorology and also the air quality. So in the other pollutants, usually for haze, the issues are either in west coast of Malaysia, basically from our local burning, and also from Sumatra, the forest burning. And at the same time, for during haze, we experience the bad haze in Kuching, Sarawak, basically from the local and also from the Kalimantan forest fire. So the haze air pollution, the definition, haze consists of sufficient smoke, dust, moisture, vapor suspended in the air to impair visibility, and it is considered transboundary as if its intensity and extent is so great at source that it remains at measurable level after crossing into another country airspace. So basically for Malaysia, we have our local sources and also transboundary for Peninsular West Coast from Sumatra and forest fire, and also from the East Malaysia, especially in Kuching, from the local and also from the Kalimantan forest fire. And this is, sorry, the same API. For the history of Malaysia, as I mentioned earlier, API, we don't have, 1983, we don't have the API yet. At that time, we just use visibility to measure the air pollution. But since 1997, we have the API that was worse in Kuching, worsened by the El Nino, and a state of emergency was declared in Sarawak and also in Semenanjung. And this is basically caused by the forest and pit fires. That time we have 29 CAQM in 1997, where we started 25 in 1995. And all of them exceeding the PM10, exceeding the Malaysian ambient air quality guidelines, MAAQ. In 2005, we have another episode of haze, where the haze emergency was declared in 11 August. Basically, we have the API of 541, and few flights were suspended during that time. Again, all the other episodes, either in Sarawak again, Sibu, and this is Muar is very close to Malacca, 432. This is very close to Medan in Central Sumatra in 2010. So during haze, more than 170 schools were closed in Muar on 21st October. Again in 2013, also in Muar, Muar is Johor, a state of emergency was declared again. And 2015, another worse haze due to this prolonged haze duration more than 2 months because of the forest fire. So again, this is a similar thing that I shared just now. So the sources of haze could be due to the land use changes, slash and burn, oil palm plantation, pit combustion, and also the anthropogenic activities. And we can have the source of haze based on the satellite image by NASA for 2015 and also 2016. So, and during the 2000, we also have another haze in 2019, especially in Klang. This is very near again to Sumatra. And during this time, we use our airbox sense, the low-cost sensor, to do our own monitoring. And we compare with our CAQM. It's almost similar. And we could, with the airbox sense, besides PM10, the dark one, we could also monitor PM1, the blue one, and also the PM 2.5, the orange, and CO, carbon monoxide. Then This is PM particulates, and this is the carbon monoxide in PBB monitoring. And we can see that during 2019, the haze episode, which is from in March 18 to, this is a one day monitoring to 19 March, we can see the air pollution, the particulates matter increase, and also the CO also increase. And when we compare our haze during the air quality, the major air pollutants during the movement control order due to the COVID-19 pandemic in Klang Valley. So Talib et al. Has published this. We can see that during COVID-19, especially for PM10, during MCO, we call it movement control order. This is before movement control order. This is the status of PM10. We can see the usual air pollutants, but during MCO, it is slowing down for PM10 in Shah Alam, but you can't see it in Putrajaya much changes in Putrajaya during MCO, because the Putrajaya mainly are the government offices, and during MCO most of the does not apply for the critical services. So that means the traffic is almost just slightly reduced, but in other areas such as in Klang, for PM and other states, you can see that like in Batu Muda, you can see the decrease of PM monitoring, PM concentration during the MCO as compared to before MCO. And also we can see into other pollutant monitoring. So you can, later you can go slowly to look into this comparison before and during our lockdown during COVID-19 of the air quality status in Klang Valley, Malaysia. So now I would like to share about this low-cost sensor. We have our Airbox Sense and Research team in UKM. This is our team. They are all mostly the atmospheric research group people, and we have the atmospheric scientist, Dr. Sharul. For Shawal, the electrical engineer. We have the software engineer, Dr. Muhammad Ahmad, the big data scientist, mathematician, and also the dashboard developer, mathematician, and also our technicians, the instrumentation and analytical scientist, Dr. Haris. So this Airbox Sense, it is a low-cost sensor. It is portable. It has the sensor element, sampling capability, power system, batteries and power supply, sensor signal, data storage, data transmission, server-side software, and also housing and weatherproofing. So these are the Airbox and all those sensors. And what it can monitor the gases, VOCs, NOx, and ozone, CO, and SOx, particulates, and also environmental temperature and relative humidity. And they have it also have independent power such as battery and solar, and independent communication, and also you can use a GPS, and easy to install and online data processing. We use RSOP Studio to analyze the data. The data is actually every, if I'm not mistaken, 1 second or 15 seconds. They monitor this Airbox Sense. So a lot of data. And also they have come up with a new Airbox Sense for various gases, for all those air pollutants, using the different transducer. And this Airbox Sense is a benefit to the public. It can be placed at the lamppost, near to the roadside, or even in a building, even use it to monitor our railway track, the stations, whether is there any pollutants, and it can be used for air quality management plan. And we hope that we could, this airbox sense could have the application, then it can be connected to the headphones, to the mobile phone. So there are some publication from this airbox sense, and they are planning for this roadmap. They are also using airbox sense, using the drone to go for the area that is unreachable for the air quality monitoring system. And they also are coming up with the AquaSense for water pollutants and also geohazard sense. This is by our UKM team. Okay, now I think enough of this measurement. Before I go into the details of the diseases, I just like to highlight, because we are talking about the haze, the high impact of haze, especially globally. 32% of population live in the area exceeding WHO interim report of 35 microgram per meter cube. This is the first interim of WHO 2021, or we call it, or is using the, because this is published in 2004, means they are using the WHO guidelines of 2006. So especially high proportion of this population that are exposed to high level of air pollutant in East and South Asia. East Asia and also South Asia. So the exposure assessment, exposure to fine particulates can cause severe impact on human health, and smaller particles are more hazardous because they may remain longer in the atmosphere and also penetrate more deeply in the lung, into the lung, and susceptible group with pre-existing lung and heart diseases, as well as elderly children, and they are particularly vulnerable. So for haze, when we started with the health effect studies, we have documented few of the 1997 haze and published few of them. And these are some of the publication by our Malaysian and also by other countries. In Singapore, there were more of 30% increase in outpatient medical care due to the haze. For my own publication, when we first analyzed the haze, we use the case crossover, and we only analyzed for Klang Valley, and data was obtained from the mortality data from the statistics department using ICD-10, sorry, and the air quality from the Department of Environment. And we found that during the haze, the highest risks are for the respiratory female 15 to 59 years at lag 5, and then also for natural mortality of less than 14 years old children at lag 2, and respiratory male more than 60, the elderly at for elderly, and next is the respiratory male again, and also in general the respiratory odds ratio for the whole population is about 1.91. This is actually almost similar to the one that has been reported elsewhere for the particulate matter death. So any question on this for my first lecture on the fundamental of air pollution? I'm not sure how. Oh, I have exceeded the time. Sorry. So it's more than 1 hour. So any question for me?
Yeah, there is one question from Novita.
Oh yeah, okay.
Yeah, let me read for Prof. Mazrura. Novita asks about differences of air pollution condition between low and middle income country. She asks, is there a difference in the sources of air pollution between low and middle income countries and high income countries? What is the number of diseases caused by air pollution there? Is there a significant difference?
Okay, yeah, there is for low and medium income countries, there are differences in terms of their sources. for the low and medium income country, we are mainly, our sources are from the biomass burning, especially for cooking, and also for fuel. But for the high income country, they are mainly industries. So that means when they low income countries where we use a lot of biomass, then we can expect that the air pollutants are mainly the particulate matter, and also some with the criteria pollutants, in SOx, NOx, and CO. A number of diseases caused by air pollution there. Is there any significant difference? Yeah, I think I can share with you our systematic review that is published my PhD students. It was published in 2021, where he compared the air pollution sources of he reviewed systematically the air pollution sources of LMIC, low and medium income country, and also what are the level of pollutants, and also what are the diseases causes. The diseases are basically the main diseases of concern for air pollution are the respiratory and the cardiovascular diseases. And the number of diseases, surely we will be influenced, especially when we look into the mortality, the death, and also the morbidity. That means the admissions, the emergency room visit, and hospital admission for the respiratory and the cardiovascular diseases. And when we compare with the LMIC with the high income countries, since our main sources are the biomass burning, so we are talking about the particulates. So the diseases are mainly also the respiratory and cardiovascular. If it is high income country, basically they are talking about industrial air pollution, the hazardous air pollution, then we go for the toxicology. I mean, you have to know what are the main chemicals, air toxicants. So then only we go for their toxicity. I hope I answered that.
Novita, bagaimana? Cukup jelas?
Please remind me to share the papers, Dr. Yusniza.
Oh ya.
Because this is a good paper that reviewed the LMIC issues of air pollution in our review.
Okay, insyaAllah. Okay,
And
is there any question for Prof. Mazrura? You may raise your hand. Click the icon raise hand, please. I think clear for this.
do we take a 5 minutes break? Just
okay.
in case,
Yeah. Please.
is anyone like for let's just call.
Yeah.
Assalamualaikum, boleh kita mulai? Mungkin tak sempat 5 minit ya.
Ya, Waalaikumsalam warahmatullahi wabarakatuh. Prof. Mazura
Ya.
has one question from Muhammad Nasir.
Oh, okay.
Yeah,
Sumber, proposal, okay.
yeah.
Mazura.
Air pollution from medical waste incinerator emits PM 2.5 and PM10, which come from fly ash residue. Inside the fly ash residue contains heavy metal. His question, can this heavy metal stick to PM 2.5 or PM10, which is emitted in the incinerator chimney?
Yeah. Okay. Yeah, I think PM 2.5 and PM10, they do attach, the heavy metals do attach to these particulates. So for incinerator, but I can't remember what are the main heavy metals, but basically I think incinerator, I have to look at, usually it depends on the incinerator, especially for the medical waste, the clinical waste management. So we have at their feeder, I mean the raw materials, and even for my experience working for the high impact assessment to develop the medical waste incinerator, because medical waste incinerator is a Schedule 2 activity which require, before establishment of this incinerator, they need to undergo the EIA process in Malaysia. So usually when they want to come up with this, to develop this incinerator, they have to go through exercise, EIA exercise, availability exercise, and it depends on the raw materials. And what I did last time, when we do the model, we really model for the heavy metals, but I can't remember. But basically, the heavy metals are concerned, such as lead, arsenic, cadmium, chromium. They are the main four heavy metals of concern. Most probably, also one is mercury that we look, because in medical waste, most of the healthcare facilities, we use a lot of the thermometer, especially if it's broken, then they have to send to the incinerator to be incinerated. So these are the at least 5 heavy metals that need to be monitored for incinerator. But they can have a long list of heavy metals to be monitored from the incinerator. But it is very specific for each plant. I mean, that means it can be different plant have different emission. So we can model the health risk. We can calculate based on the air quality modeling. That is we have to refer to the air quality consultant to get their data for us to model for the health risk. I hope I answered that. Cik Muhammad
Nasir, apakah sudah jelas? Is it clear? Okay, we can move to the next presentation, to the next session.
Yeah, thank you, Ibu Yusniza.
Yeah.
Okay, so for my next slide, how many that I have, I can't remember. So it's a lot. Sorry, I have to go fast because I only have half an hour for this. Okay, the learning objective to look at. I think we have gone through this and identify who are for air pollution and diseases, who are the most susceptible people, susceptible to the negative effects of the air pollution. Understand the biological mechanism linking to air pollution and the health effects, and local air issues and describe our role as the public health practitioners in the health risk management. So the outline is, I think I've done that, the global burden, vulnerability of air pollution effect, respiratory system we look into a little bit, and health effects of criteria pollutant, especially for the biological pathway of the air pollution, pathway of PM 2.5, promoting cardiovascular event. This is quite recent. This I think this publication only a lot come up after 2017 by et al. 2017, talking about the biological pathway of PM 2.5, promoting cardiovascular or cardiometabolic diseases. The high effects of hazardous air pollutants, this mainly referred to toxicology, little bit of IAQ and indoor air quality and parameters. Usually we refer to our, in Malaysia, Department of Occupational Safety and Health. We have the industrial code of practice of IAQ and some risk management. So I think we have seen this. The air pollution is silent killer, where it could cause 7 million deaths every year, especially in our region, Western Pacific region, and also Southeast Asia Pacific region. The major air pollutants, PM10, ozone, the criteria pollutant, and also lead. The air pollution moves up on the global non-communicable disease agenda, whereby air pollution is the second leading cause of death from the non-communicable diseases after tobacco smoking. So, so air pollution is the most important exposure, the risk factors, and it causes the NCDs of basically cardiovascular, because this is well known, the respiratory and cardiovascular, and cancer basically due to the hazardous carcinogens. But the new update on these air pollution diseases, because it's influenced the diabetes because of the metabolic changes, because of the air pollution, and also the effect for the oxidative stress, and look the effect to our nervous system. So as this is have mentioned earlier also, urban air pollution contributed to 800,000 deaths in Asia, 800,000 deaths per year, and 2/3 was in Asia. And the global of disease by risk factors, this is quite recent, by 2019, the IHME Institute had metrics and evaluation, and the global burden of disease risk factors studies is by WHO. They have estimated that mainly the environmental pollutants cause the main death. The global estimate of more than 800,000 deaths in there is similar to the smoking and second-hand smoking. So the main global burden of disease is mainly by the environmental pollution, and mostly this environmental pollution are mainly due to air pollution. So this global burden of disease for major air pollutant, this is the global approach. So you can see that by sectors, these are the sectors they have. I think we just look into Indonesia when they estimated the global burden of disease for major air pollution sources, the GBD maps global approach. This is by McDuffie, 2021. I have the main the paper that I can share also. So by sectors, we have this legend for sectors: the agriculture, energy, industry, non-road transport, road transportation, and residential. So Indonesia basically the source of the global burden, the major air pollutants are mainly from the residential, coal, biofuel, and remaining is the light blue one. And for the fuel type, it is mainly fuel type, the gray one, the solid biofuel, and also the light one, and other sources. And in terms of death, 18 microgram per meter cube is equal to 94,000 death. If almost to 20 microgram, it would cause more than about 100,000 death in Indonesia. So the diseases of concern, basically the cardiovascular diseases, that is the stroke, the blue one, ischemic heart diseases, and the type 2 diabetes, COPD, and also the lower respiratory infections, and also lung cancer here. This is the IHME calculation, where they look into the and the map the GBD. So susceptibility it is important for the health effects, the condition of state of vulnerable to a disease or condition, and vulnerability being in dangerous position, and encompasses susceptibility, exposure, and also susceptibility. So we have this vulnerability, we have the susceptibility, exposure, and sensitivity, and also how we adapt and how we are exposed to the risk, and we have the effects, the outcome. So for Malaysia, our top main causes of death in Malaysia in 2017, basically circulatory, means the cardiovascular. Second is the respiratory diseases. So that means the it could be also related to the air pollution for Malaysia, and besides the other risk factors such as lifestyles. For the top two death of in Malaysia in the government hospitals. We also have the top four, the neoplasm means cancer. And however, our infectious diseases are still top three. I think this, after 2020, this little bit changes that you can see, whereby due to the COVID, we could see this one could be number 2. Okay, respiratory system, I think most of us knew this because you are all health, environmental health students. So we have the respiratory system through inhalation tract, and we breathe 12 to 15 times a minute. And we have all these respiratory system, the nasopharyngeal, tracheobronchial, and also the pulmonary alveolar system. So lungs serve as portal of entry, where highly permeable and lots of blood flow, and also we have a high pulmonary alveolar surface area, more than 75 meter cube, for the gas exchange to happen. So these are the gas exchange, whereby the lungs take up our oxygen, bring it to our heart, and the heart will pump the oxygenated blood out. Okay, the natural protection for respiratory system, we have our natural mechanism, especially for the particles. For the nasopharyngeal, we have our nose hairs, our mechanism of coughing and sneezing. We also filter out the dust away, and also mouth breathing. The tracheobronchial, we have the mucociliary escalator, and also bronchial constriction, means we have the mucus to thicken to trap all this dust. And in the pulmonary alveolar system, we have the macrophage, which will trap the dust and digest it, phagocytosis. And these are the mechanisms of the cleaning mechanism and the rate of cleaning. For cough is immediately. For ciliary, it's about, for large bronchial, half an hour. Bronchial 3 hours, and bronchial airway 6 hours. So it takes time to clear up the air pollutants from our bronchial airway, and for the alveoli, it will take about 24 hours to clear up. And for the lung tissue, it will take months or years. That's why we look into we have, for workers especially, we have the mineral dust regulation, and we have respiratory protection system to ensure that we could protect our workers from the exposure to the dust. So biological pathway of health effects of air pollution. Basically, when we have the air pollution, it will be it goes, especially the small particles, it goes into our alveoli, and it will penetrate our blood system. In the alveoli, if it is you are asthmatic person, you can have the bronchial responsivity, and also the immune system reaction. And at the same time, it also affects our circulatory system, whereby we have this arteriosclerosis. In the circulatory system, we could have vasoconstriction and the hypertension. And also long term, it will cause arteriosclerosis, whereby there is blood viscosity, high viscosity due to the exposure to the particulate matter, and it could cause the atherosclerotic plaque formation, and also it could cause arteriosclerosis or stenosis. At the same time, it also could lead to autonomous, the particulate matter goes into our systemic effect, goes into our nervous system, where we have the effect of the autonomous and systemic reaction. So the air pollution affects health throughout our life course, even during pregnancy, in the prenatal, especially reduced growth for mothers, especially who are smoking. We could have reduced growth, and it could lead to preterm birth and low birth weight of babies. And at early childhood, when they are exposed to air pollution, the children could have decreased lung growth, reduced lung function, respiratory infection, including pneumonia and environmental effect, and long-term effect, the chronic respiratory and cardiovascular diseases. And who are the most susceptible? Basically, children under 5 years old, because their lungs are not yet full developed, and the children inhale more air per unit of body weight than adults, and they are prone to greater health effects as well as long-term damage to the lungs. Similarly, asthmatic and those suffering from chronic respiratory and heart diseases, whereby they are in already weakened state, so air pollution adds stress to their bodies. And for elderlies, the air pollution increase their susceptibility to viral and bacterial attack, as their both lung and immune system decrease with age. So these are the most susceptible population that we need to protect: the children, those with underlying diseases, and also elderly population. And the major pollutants directly affecting health, basically the criteria pollutant. We emphasize a lot on the particulate matter, but not to exclude not the other gases, and also lead and other mixture from important pollutant settings, such as the household fuel combustion and also traffic related. So the hazardous air pollutant, the air pollution and their health risks, as we have seen the criteria pollutant, the hazardous pollutants, such as the question on the heavy metals and also organic compounds, and other sources, not to forget the bioaerosols, such as all those allergens, the SARS, COVID-19, the swine flu, avian flu, and Legionella pneumonia, especially in the sick building syndrome, or in the indoor air quality. The effects could be acute or during the air pollution episode, such as haze, or through the methodology that we can use, the epidemiological studies using advanced statistical modeling, or we could use a chronic and also other methods such as toxicological studies and the pollutant interaction. For Malaysia, I have one of my master students graduated looking at the toxicological effects of the particulate matter of the coal-fired power plant. So for particulate matter, we refer to the wide varieties of airborne material, basically from manifesting as dust, soot, smoke, or smoke. So we have all these PM, particulate matter, but at the same time there are a few others pollutant attached to it, such as the heavy metals and also the organic compounds. So the particulate matters, they have the largest impact on global health, and it depends on the particle deposition to the respiratory system. So the smaller the particles, it can go deeper into the alveoli system or the lower respiratory tract. In fact, it can go to the trachea, bronchi, and alveoli if it is less than 2.5 micron. So the health effects of PM depends on the particle size and chemical composition, whereby it penetrates deeply into lungs to alveoli and irritate our lung lining, especially the asthmatic people are very sensitive, and stimulate immune system like inflammatory proteins. So these are the particulate matter air pollution size. I think we have seen that earlier. And the position, the physiology, the air pollution epidemiology, usually the PM ambient air quality standards are based on the epidemiological studies. It is used real world exposure and health responses. We have seen that in the London smoke analysis, and it can examine different segment of the population. And we can look at elderly, asthmatic, and children, and use the skill association to infer effect of the air pollution. So for particulate matter, as we have seen that besides the dust, the particulate matter sizes, the different sizes, we have also other components such as the elemental metals, the sulfate, the PAH, the heavy metals, the heavy PAH, the light PAH, the bioorganics, and also traffic traces. So for PM10, we also we look into their health effects, and it PM 2.5 it goes deeper and may absorb chemical, and their intensity will increase their health effects, and also it is toxic or carcinogenic depending on the chemicals of concern. Is it pesticides, lead, arsenic, or radioactive materials? And there were reported that 8% increase in lung cancer for each 10 microgram of increment of PM 2.5. So the respiratory effect, so we can see that the short-term exposure to PM10 has been associated with significant increase in hospitalization, emergency room visit, home medical visit, mainly from COAD, COPD, asthma, and pneumonia. And inhaled PM10 can be deposited on different airway segments, some of which can enter the blood circulation through our air-blood barrier and resulting in oxidative stress and subsequent lung and systemic inflammation. So when we inhale, we have our oxidative stress at our airway epithelium, and it goes into our, it penetrates into our blood system, and it goes into the capillaries from alveolar, terminal bronchioles and alveolar cells to our capillaries, and it could lead to systematic oxidative stress, where it cause systematic inflammation, where we have the cardiovascular inflammation and the endothelial dysfunction, platelet aggregation, and vasoconstriction. And this could lead to cardiovascular effect together with these autonomic nerve cells, whereby it could lead to the arrhythmic potential, high increase of the heart rate or tachycardia, heart rate variation, and also vasoconstriction. But at the same time, the systemic effect, the cardiovascular inflammation, just now we can see the thickening of the endothelial cell, and all this could lead to the cardiovascular effect. This is the same. And again, this is the pathway for the cardiovascular event. This is quite recent, 2018. I think similar to that has been shown. Either the PM 2.5 first, it goes into the ANS. This is what is this? I can't see. The autonomic nervous system imbalance. It induced the ANS imbalance. We cause basically the vasoconstriction. And second pathway is through the systemic inflammation of spillover of the cells, some of the cells, especially the cytokines, and also this toll-like activated cells, all the cells, which could lead to the systematic inflammation. At the same time, it goes into the systemic, where the circulating PM consistent, it goes into our blood system, and it activate and inflame the tissues, especially our blood tissue, the blood tissues, vascular tissue, hypothalamus, liver, and bone marrow. And all this could lead to acute and chronic pathway, and this has been known earlier, before 2004, and this is quite recent, that because of this systemic inflammation spillover is also circulate mediators and cause oxidative stress and inflammation, and it's caused the metabolic disturbances, and it could lead to high incidence of insulin resistance, where it will make worse of diabetes and obesity. So there's a lot of new findings now in terms of association between air pollution, especially particulate matter, with diabetes. PM epidemiological studies, association could be short-term and also long-term. Long-term, we could see, and they will detail out for long-term, for example, a cohort. But for Malaysia, we still have not been able to conduct our long-term exposure for cohort, but basically for our long-term, we only conduct time series studies. So for Asia, we have PAPA, Public Health Air Pollution in Asia. It's being organized by Health Effect Institute. I was part of the team which organized in Hong Kong, Shanghai, China, Bangkok, Thailand, and also Indonesia. I think after 2008, other countries also joined, Asian countries, to be in part of the PAPA studies. They have published quite a number of publications since 2008 in terms of time series of PM10 and mortality and mobility. This is the short-term air pollution that I think one of my first publication on air pollution and mortality by my colleagues, my PhD graduates, and we've run our own time series modeling, and we found that there were association of air pollution and mortality using this Poisson regression, and ozone, CO, and PM10 were the important pollutants. However, we have only seen the effect of not really the significant effect between ozone and mortality, but we can't show PM10 effect unless we do multiple pollutant model. And I have also published this hazardous air pollution in Asia, in Malaysia, sorry, this book. And then now we go for the criteria pollutant. The carbon monoxide, we know that carbon monoxide is a competitive inhibitor for oxygen, so it will react with hemoglobin in blood and form carboxyhemoglobin, and the effect will be affecting we become hypoxic. We don't have enough oxygen, so that at low level we have the cardiovascular, means we will have some headache and can go for high level headaches, nausea, vomiting, and fatigue, and possible death. For vulnerable people, especially those with the chronic heart and lung diseases and anemia, so they are more vulnerable for this carbon monoxide poisoning. And also smoke also increase the carbon monoxide level. And second, the third pollutant is ozone. This is mainly because of the photochemical reaction. The source are basically the stationary and the mobile sources. The head effects basically ear, nose, and throat irritation. And the chronic effect is irreversible accelerated lung damage. And it could cause death from the respiratory causes. Ozone, it is colorless, have a lot of oxidized protein and highly irritants to lungs lining, and just it is very sensitive for asthma patient because it can trigger bronchospasm and because inflammatory cells, which could lead to thickening of the lung tissues, and also increases responses to allergens and damage our infection fighting responses, and it could lead to chronic lung damage. Ozone head effect, basically irritation, cough, wheezing, reduced lung function, and worsen asthma and COPD. And we can see a lot of emergency visits and hospital admission due to asthma, and mortality, high increase of mortality, usually during this high episodes ozone level. This is the during normal and also asthmatic because of the constriction of bronchoconstriction. The previous WHO guidelines, I think you can refer also to better refer to 2021 WHO guidelines. NOx basically from pure combustion and mobile and stationary sources. Prolonged exposure could lead to pulmonary fibrosis, emphysema, and also lower respiratory tract illnesses in young children. The acute effect is at 10 to 30 ppm, and it could lead to nose and lung irritation. And nitrogen dioxide is this respiratory irritant. NOx is usually the last, call it the outcome of these secondary pollutants. All the salts and ozone will ended up as nitrogen dioxide, and usually nitrogen dioxide is a good indicator for the mobile sources. It could lead to decreased lung function, slower lung function growth, and asthma exacerbation and risk of developing asthma. SOx basically from the burning fuel, such as the power plant, diesel trucks, and gas and particulate phase, and head effects, short-term, intermittent, bronchoconstriction, ear, nose, throat irritation, and secretion, mucus secretion, and long-term exposure could lead to respiratory illnesses and also exaggerate the heart diseases, and it is intensified in the presence of PM as we have seen in the London smoke issues. So all these are the effects of pollutants, either fine particulates, particulate matter, ozone, carbon monoxide, sulfur dioxide, lead, and also nitrogen dioxide. So we can see lead, burning fuel that contain lead, especially battery processing, car battery smelting. So lead absorbed in blood, similar to calcium, and accumulate in blood, bones, and muscles. Basically, the most important head effects of lead, besides the organ effect, is the CNS. Because of this, the Needleman in 1983, she has shown that the lead has shown IQ reduction among children. So US EPA revised the lead level, especially to protect our children, because lead could lead to low IQ and learning disability. So hopefully we could protect our children, especially I'm concerned because I have seen some news or videos about lead smelting in battery smelting. It is being done at home and exposed in like a backyard industry at home, and it exposed children playing around the houses. So we are very concerned if this lead exposure could lead to central nervous system effects, and also reduce the IQ of the children, and could lead to learning disability. Other head effects of lead: heart and blood, high blood pressure, and also chronic poisoning. So for my master in public health, I was doing lead exposure in battery factory manufacturing company, and I also analyzed for the neurobehavioral effects of these workers exposed to lead. Mercury, high elemental mercury is inhaled as vapor, It's caused by vaporized mercury. The sources are coal combustion, accidental spill, and also mining. Effect is nervous system, CNS, respiratory system, and also kidney, skin, eyes, immune system, and also some mutagenic effect. So others, HAP, then when we talk about incinerator, either it is clinical waste or shadow waste incinerator, usually we are very concerned about dioxins and furan. This is dioxin, chlorinated D-benzo P-dioxin, CDD, and PCBs, and also CDF. It is caused by burning chlorine-based compound with hydrocarbons in basically the source waste incinerator. So dioxin, we have to look into the toxicity, especially with the high exposure. And the concern are also, besides the systemic effect, the reproductive and the developmental effect, is also dioxins are carcinogenic. So it is anticipated as a human carcinogens. Besides that, we also have chloracne if we are exposed to this dioxin. These are the dioxin. And other research that I've done is on the PAH of in PM10 in an urban area in Malaysia. So we have seen that we also calculated the health risk for this PAH and in PM10. And we found that during haze, especially, I think if I'm not mistaken, the benzoapyrene are the main PAH are concerned. However, luckily, the health risk from the exposure to benzoapyrene were negligible when we calculate for the health risk. Other aerosols, other pollutants are aerosols, either with the organic origin, either such as the microorganisms or pollen, and source are human, non-human, such as wind wave, wastewater treatment plant. The health effects could be allergies to pollen or to death due to the pathogenic infectious diseases such as the viruses, the COVID-19, for example. We have seen all this airborne transmission, and also the airborne transmission, the importance of the IAQ, the sick building syndrome, and also not to forget the biological warfare, where they use this biological the microbes to induce the anthrax or Ebola virus. A little bit of the indoor air quality, we have seen the biological related illness. This indoor, which symptom that can be related to the building or airborne building pollutants, such as the hypersensitivity pneumonitis or Legionella disease, or sick building syndrome, which used to describe which building occupants experience acute and comfort effect that appear to be linked to the time spent in the particular building. When they leave the building, that means the sick building syndrome will be lessened. So we have to differentiate whether it is BRI or sick building syndrome in terms of the effects. So for IAQ for Malaysia, we usually use DOSH Industrial Code of Practice 2010. So there are 11 parameters: air temperature, humidity, air movement, the chemical contaminants, CO, formaldehyde, ozone, respirable particulates is mainly the PM10, TVOCs, biological contaminants, that is bacteria count and total fungus count, and also the ventilation performance indicated through monitoring of the carbon dioxide. And then for air quality management, we know that the sources are mainly by sectors, especially by transportation, waste management, industry, and power and energy. So if we want to manage this air quality, we have to go by the solutions by their own sector. So for transportation, we need to advocate more of public and active transportation, and especially we need to build up more the railway transit. For example, in Klang Valley, we have the LRT, low railway transit, and also MRT mass railway transit. So there is to address the issues of emissions from the traffic vehicles. So at the same time, to monitor this transportation, we have the emission standards on vehicles and cleaner fuel engine technologies, and we are also towards the cleaner fuel. We are moving towards Euro 4 and Euro 5. Then we have the waste management, especially during this El Nino, we ban all the open burning. And for waste management, we have the waste to energy technologies. For example, a lot of the skilled shadow waste facilities, for example, either for clinical waste incinerator or shadow waste incinerator, they are coming up with this waste to energy technologies where they capture the methane gases and convert that into energy. So with this, I have been involved with many of these waste to energy EIA to assess their high impact. Industry, energy efficient technology and continuous maintenance, especially for industry, they must have what do you call it? The system, clean air system, better, what is that? Clean air pollution control, APC, air pollution control system, to ensure that their emission could meet their standards. And we hope to replace natural gas, to use natural gas to replace coal, but the issues are natural gas usually very expensive, and also coal much cheaper, but then coal with the low sulfur contents are much expensive, but it is better than the coal with high sulfur content. So they have improved the technology for example, the power plant with the coal-fired power plant. Some of the new power plant in Malaysia, they have used the natural gas, and you use the combined cycle, or they have the mixture of coal and also natural gas. So, and also the cap and trade of tax policy. This is the pollutant pay principles for the industry. Same time, for air quality management, we are looking into, in Malaysia especially, renewable energy. For example, replace gas to replace coal, and also emission monitoring, and part of it also the renewable energy such as waste to energy, biodiesel, what else? Can't remember. And also we have the continuous emission monitoring and air quality monitoring in place. And us as the public health practitioners, we need to be aware that the air quality in environment, especially if there may be sudden changes in air quality, we can check the air quality index world map, the IQ Plus. I think this IQ Plus was developed by Switzerland, and it is available. I think we need to register, but yesterday when I looked into it, we can go into, but with certain restriction for the daily air quality condition. For Malaysia, sometimes we usually goes first to the Department of Environment Air Pollution Monitoring Station, APIMS. So if they are high, the bad air quality, is better to remain indoors as possible, as on poor air quality days, to reduce our exposure to the pollutant. If walking or exercising outdoor, try to avoid areas with high vehicular emission traffic or known pollution sources. So the clinical solutions are limited, means that when we are exposed to the air pollution, for those especially with underlying diseases, they are easily getting all the head effects, means that they can easily got the shortness of breath or ischemic heart or cardiovascular diseases. So that means to wait for the clinical solutions is very limited. This means that with this worsening of the respiratory and the cardiovascular diseases, they usually need to be admitted, and recovery because of this moderate to severe high effects of air pollution are much difficult as compared to our prevention. So the public health solutions are required, because for us in the public health, we are basically looking at the prevention, basically more on the protection of the environment, such as control of the air emission. So as a PH practitioners, we need to advocate on clean air initiative. We have to have improved awareness of air pollution in the global health community. We need to join a global network of informed health oriented campaigns. So that means you can be the champion to to advise, to advocate our public in terms of air pollution issues, especially the immediate one is the smoking, and also some sources of air pollution from the biomass burning and traffic. We have to educate the public, and we have to increase public awareness of high impacts of air pollution. And sometimes we need to exert political pressure for the clean air action, to have our clean air, healthy air. So that's all my lecture. Sorry, I think I exceeded time. We are now 12:15, but I still can open for any questions if you have any questions.
Okay, there is a question from Desi.
Okay.
Already one question from Desi. She said, air pollution is a big problem in many big cities everywhere, which among other things result in health impacts. The causative factors include movable sources and immovable sources. What are the existing policies in Malaysia regarding the handling of air pollution and its health impact?
Thank you, Casey, for the question. Okay. For the main sources of air pollution are the mobile and also stationary sources. So for the mobile sources, that is the traffic. For the stationary sources, mainly the industrial pollution. For Malaysia, so we have the act, that is the EQA, Environmental Quality Act 1974, with the amendment in 2021. So this Air Quality Act, they have revised, whereby they emphasize more on the healthy environment to protect our human health. I was also one of the panel to come up with this new amendment for the EQA. So in terms of this EQA, means that for especially for stationary sources, so we have different government agencies that monitor the stationary sources. Means we have the Ministry of Transportation to monitor the emissions for the traffic vehicles, but they work together with Department of Environment to know the environment, the air quality status of Malaysia. So all this, they have another regulation to ensure that the traffic emissions are being controlled from the motor vehicles. Means that they need to improve the fuel sources. Means Malaysia is moving towards from Euro 2 to Euro 4. Means that for Euro 4, that means we try to stop the using of the old vehicles, because the old vehicle usually use Euro 2. Euro 4 means we could improve in terms of the fuel, and that's one of the measures to improve our air quality. But at the same time, all the motor vehicles, they need to be inspected. They have regular inspection, so that they don't, to ensure that they, especially for very old vehicle, if it is more than 10 years, they need to undergo special inspection for them to be able to have our road tax. But the other measures for this traffic emission is we try to impose on to berkongsi kenderaan, but it is not effective. Just to reduce the mobile sources. That's why for urban center like Klang Valley, the Kuala Lumpur, and its conurbation, we have this LRT and MRT. So a lot of people are using LRT and MRT to reduce traffic congestion. Okay, that's the one of the measures for the traffic emission. For the stationary sources, as I mentioned earlier, stationary sources, we have the regular air monitoring. Means that all industries need to monitor their air emission, but at the same time, before they are being built. So for those industries, the stationary sources, for those industries which are prescribed activities, there's a lot of industries activities, they have to undergo EIA, environmental impact assessment, whereby they have to go through all this exercise, and also during this exercise, they have to come up with their environmental monitoring plan, how they are going to be monitored their environment, that means air, water, soil, when they are in operation. So that are the one of the policy that measures how we address the what you call it, stationary sources. And also government is also promoting the clean air, clean fuel, clean technologies, we call it greener technologies, and they have think there are some taxes reduction, taxes incentive for those industry that have use cleaner technologies. But what else for this technology? And they have to ensure that for the emission to be the air quality, the air pollution to be controlled. They have to ensure that they have the air pollution control mechanism for each industries. I hope we address that, bagaimana kebijakan Malaysia terkait penanganan pencemaran udara dan dampak kesehatannya. Okay, and since 1997 Haze, Department of Environment work very closely with Ministry of Health when we look into the high effects of environmental pollution, such as air pollution. If it is water, MOH, Ministry of Health have their own engineering division with which monitor our drinking water quality. But for air pollution, they are very close contact with Department of Environment and MOH. So they usually have a very good collaboration, and it's when with this we are prepared to face the haze condition these few months, coming months. Usually we are expecting the haze from now, May to at least September. And we have this National Environmental Action Plan. We have the TWG for air pollution, and in this DWG Technical Working Group, we have most of the government agency together to work together to coordinate all the activities, how to address issues of environmental pollution, especially air pollution and the health effects. I hope I answer this, because when they work together, especially when we are anticipating that the haze is coming, so they know that what will be the health effects, especially our vulnerable population, the elderly and the children, and also those with the underlying disease. So this means that in the TWG, Technical Working Group for Air Pollution, they have especially people from the schools, from the primary school, from the nurseries, to ensure that if to protect these children, and from the elderly association, not the elderly association, the Ministry of Community, which needs of Women and Community Development. So they will be Department of Environment will ask MOH to advise all this ministry what are the control measures or mitigating measures to do when they are facing bad air pollution condition. So they have a lot of meetings to address all these issues, upcoming issues. Okay, is it okay with that answers?
Okay, Mbak Desi, ya, bagaimana? Apakah sudah jelas? Is it clear? Any other question? Please. if you want to ask directly, you may click the raise hand icon, please. Any other question? Okay, Prof. Mazrura.
Yeah.
Actually, last year we have visited to Malaysia, and we also visit one air monitoring station in an elementary school in Kuala Lumpur, if I can remember, yeah. And it's quite interesting. And also we visit the EDC, as in our flyer is in EDC in Malaysia, right? Environmental Data Center, yeah. It's and our flyer we visit in August last year.
Oh, last year. So,
Yeah.
you are coming again this June, is it? Are you coming together?
Yeah. Next agenda is June.
We could your visit to UKM, especially with
yeah. Actually, I cannot join. Other lecturer will be joined. So maybe one of our destination in UKM. We will contact you later if we
you can I can connect you with our atmospheric research group. And whoever is coming to Malaysia, it's very good that you can visit us in UKM. And not if you want to look at the high volume sampler, you can visit to our to my faculty. Faculty saya bukan di main faculty, main campus. Faculty Sciences adalah di Kuala Lumpur. UKM, the main campus in Bangi. So Prof. Talib and the team, atmospheric research team, they are in UK Bangi, our main campus. So you can visit them in Bangi. It's in Selangor, about 30 kilometers from Kuala Lumpur. Actually, it's nearer to the airport, KLIA, Bangi, and we can bring you to see our air monitoring station, especially the airbox sense.
Oh yeah.
A lot of activities. Prof. Talib can give some presentation and site visit to the airbox sense, and also to our lab laboratory for the analysis of heavy metals and VOCs, the ICP-MS and also ICP-MS. If I'm around, tell me early, I can to join you all at UKM.
Okay, maybe Pak Mursid will arrange the schedule. From 18 to 22 June, I think.
The mahasiswa mereka akan datang bersama ya? Ada yang ikut bagus.
About 30 students from under bachelor and master degree.
Oh, good. And we can also link up the students with our students.
Yeah,
it's good.
Okay, any other question, participants? I think it's such an interesting topic. As we know that industrialization has made air quality become decreasing and everywhere, because we know that some of pollutants has been experiencing long range transport. So even from at the area far away from the source, sometimes we can detect the problem of pollution there. So it is our duty, our task. What would we do about this? Because sometimes we can choose what kind of air we could breathe. Sometimes we can see which one is cleaner, which one is poorer, and we cannot choose the air we breathe sometimes. So
if I may add, one of the main measures biomass burning, air pollution during this hot season, this El Nino season, I think we have also seen period whereby we have El Nino, but at the same time we don't have the haze. One of the main issues actually because haze is coming from the peat burning. So the most important is to ensure that our water management, we have enough, we call it the parit-parit dan saliran itu airnya tidak kering. So that tidak menyebabkan terlampau kering kita punya peat soil tu, dan tidak menyebabkan kebakaran. Ya, kebakaran hutan ini bukannya di atas, dia di bawah tanah. Peat burning kan, dia di bawah. Jadi dia merebak di bawah, tapi asapnya itu yang banyak kan.
Yeah, and sometimes the effect is chronic, right?
Yes.
we cannot identify the effect or have problems for only the acute effect, but we have chronic.
And I post-COVID, because of the COVID, most of us are no longer, we call it COVID virgin. Most of us have been affected by COVID, COVID-19. So we don't know our response post-COVID.
Right.
And this air pollution, we can consider ourselves as those with underlying diseases, especially post long COVID people, long situation. So we have to take care to ensure that air pollution is being controlled. Yang satunya saya rasa yang especially mahasiswa-mahasiswa kan, yang ini sudah ada yang berkahwin, sudah ada anak kecil. I'm sure that help in this being kesihatan lingkungan kan. Jadi kita harap tidak ada yang merokok di kan. Sebab saya kadang-kadang kita sedih bila ada ibu bapa yang bawa anak kecil, tapi ibu bapanya merokok di samping anak-anak. Anaknya. So we are worried about haze, but at the same time the issues of air pollution imposed by the own parents are not being yet. So
because
smoking
of the habit of parents.
I know Indonesia and Malaysia we have high smoking rate. So
right.
that role as public health professional to increase our awareness again how to improve. It's very difficult, I know, to handle smoking. So for both countries.
Okay, thank you very much, Prof. Mazrura, for your presentation. It's very interesting and informative. So sorry that Pak Mursid can join until the end of session because he has other agenda. Hopefully that this presentation will give us much more benefits to us, increase our knowledge, and also could increase our behavior to be better. So saya selaku moderator juga mohon maaf kalau ada kekurangan dari saya. Terima kasih sekali Prof. Mazrura atas tadi sharingnya, sangat menarik, especially in airborne sense ya. It's very, very interesting to us. Maybe we could have cooperation about research or other as activity. Terima kasih sekali lagi juga kepada semua partisipan yang hadir di sini sampai akhir. Semoga bermanfaat bagi kita semua dan kerjasama ini bisa berlanjut untuk yang lain-lainnya. Mohon maaf, Prof. Mazrura, any other comments to all? Maybe you want to give your statement, please.
Terima kasih Bu Yusnia, sorry maaf saya salah. Terima kasih kepada bapak-bapak dan juga ibu-ibu dosen di Fakultas Kesihatan Masyarakat. Dan juga semua mahasiswa yang mendengar sampai akhirnya. Maaf, saya pohon kerana telah mengambil masa yang agak lama. Because this air pollution and the health is my passion. Saya selalunya mengambil masa yang lama. Dan juga ada juga saya masih lagi bekerjasama dengan rakan-rakan di negara lain seperti di Jepun, Taiwan, dan Korea. Sekiranya perlu dilanjutkan networking saya kepada Undip. Saya alu-alukan, jadi kita boleh bincang nanti, Ibu dan juga Pak.
Insya-Allah.
Saya suka, katanya even in Malaysia when I have contact with universities where they have a very good in terms of from them, especially analytical skill for this type of analysis, because we can analyze the data, the air pollution data with simple statistics. So we have to use the modeling, and biasanya saya belajar dari our colleagues from these universities. I think based on my experience working with US last time, the PAPA project, it seems that we have experts in our region yang lebih dekat, yang lebih mudah dan lebih percuma. Lalunya networking kita beri percuma untuk, kadang-kadang mereka yang sponsor kita untuk ke belajar. Jadi kita buka kepada anak-anak muda untuk belajar all this new teknologi lah, kan? Allah, jadi kita tidak kira di Malaysia ataupun di Indonesia, untuk ilmu ini kita kembangkan supaya ini memanfaatkan semua. Jadi saya ucapkan ribuan terima kasih lagi sekali kerana menjemput saya, dan juga mohon maaflah kerana tidak dapat membuka kamera saya, tak dapat tengok saya, tapi muka saya sama saja. Ya, terima kasih lagi sekali.
Ya, terima kasih Prof. Mazrura dan juga teman-teman semua. Saya rasa cukup demikian yang untuk kegiatan kita pada pagi sampai siang ini yang bertemakan Air Pollution and Diseases. Semoga bermanfaat. Kita akhiri saja. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih. Sampai berjumpa kembali Prof. Mazrura. Insya Allah kalau ada kesempatan bisa main ke jalan-jalan ke UKM.
Atau saya ke Semarang ya.
Ya, ditunggu kita. Mungkin kerjasama penelitiannya. Terima kasih semuanya. Sampai ketemu lagi. Salam sehat. Sampai ketemu lagi.
Terima kasih. Bye. Assalamualaikum.
Bye.
Program studi Magister Kesehatan Lingkungan sekarang sudah berada pada tahap skala internasional. Banyak kerjasama-kerjasama yang telah dirintis dan sekarang berkelanjutan setiap tahun. Pada usianya yang hampir 25 tahun, Magister Kesehatan Lingkungan sudah memiliki skala nasional dan internasional. Banyak kerjasama-kerjasama dengan luar negeri yang sudah kita jalankan selama bertahun-tahun ini. Studi internasional, joint research, joint education, dan lain-lain, itu adalah sebagai andalan kami di dalam mengembangkan program studi kesehatan lingkungan.
Visi Prodi Magister Kesehatan Lingkungan FKM Undip adalah menjadi program studi unggul dalam pendidikan, riset, dan pengabdian di tingkat internasional tahun 2024. Prodi Magister Kesehatan Lingkungan memiliki beberapa sarana dan prasarana yang memadai seperti laboratorium pendukung kegiatan, pembelajaran, dan kegiatan tridharma lainnya. Sarana dan prasarana baik yang ada di lingkungan, fakultas, universitas, dan jejaring kemitraan dengan instansi dalam negeri.
Kolom aja betul kolom. Bulan apa? Untuk persiapan. Oke.
Lulusan Prodi Magister Kesehatan Lingkungan tersebar hampir di seluruh wilayah di Indonesia. dengan memiliki kompetensi dan profesionalisme kesehatan lingkungan yang mumpuni.
Perkenalkan, nama saya Dr. Andes Slamet Isoro, Magister Kesehatan. Saya bangga menjadi alumni Magister Kesehatan Lingkungan Undip. Semoga Magister Kesehatan Lingkungan go internasional.
Saya Tuti Rahayu, kebetulan saya alumni MKL angkatan 2014. Yang saya dapatkan selama saya kuliah di MKL sangat banyak, kemudian ilmu yang saya dapat pastinya bermanfaat di tempat kerja saya, dan saya juga bergerak di bidang kependidikan, jadi ilmu itu yang saya dapatkan selama ini sangat-sangat bermanfaat, membantu kami dalam mengembangkan ilmu terutama kesehatan lingkungan.
Sejak 2020, Prodi Magister Kesehatan Lingkungan telah menjalin kerjasama dengan beberapa institusi yang ada di Malaysia dalam penyelenggaraan kegiatan Tridharma perguruan tinggi. Kerjasama dijalin dengan Universiti Malaysia Sabah, Universiti Kebangsaan Malaysia, Universiti Selangor, Revenue Corporation SDN BHD, dan masih banyak lagi. Kegiatan yang dilakukan seperti penyelenggaraan seminar, visiting profesor, kunjungan lapangan mahasiswa ke Malaysia, joint education dan research, dan lain-lain.
Saya Fitni Hidayati dari Prodi Magister Kesehatan Lingkungan. Saya bangga menjadi mahasiswa kesehatan lingkungan. Dengan kurikulum pembelajaran dan fasilitas laboratorium yang dimiliki, bisa membantu saya dalam proses penelitian. Dengan memiliki tenaga pengajar dan pembimbing yang berkualitas, saya yakin ilmu yang saya dapatkan dapat menjadi modal dalam mengembangkan ilmu kesehatan lingkungan di masyarakat.
With this international Go program, I think it has benefited the students, and I think the Master in Public Health Undip is excellent, and the students are very active, and hopefully with this short course they have gained enough knowledge, and we hope to have further collaboration next year with Undip.
With the School of Public Health, I have been participating in the training of students in Magister in Environmental Health, and I find the program very interesting, and it covers a lot of topics in environmental health, in research and
Dengan networking yang luas, maka mahasiswa memiliki peluang dan kesempatan untuk mengikuti kegiatan yang dapat meningkatkan ilmu dan pengalamannya. Hal ini dapat memberikan dampak positif bagi mahasiswa.
Keunggulan program studi Magister Kesehatan Lingkungan adalah penyelesaian masalah kesehatan lingkungan secara global dan bercorak pesisir. Keunggulan ini didukung oleh dosen-dosen yang memiliki pendidikan doktor dalam dan luar negeri, akan menjamin memberikan jaminan mutu kepada Magister Kesehatan Lingkungan untuk melakukan penanganan kesehatan lingkungan secara prima, internasional, dan nasional.